Hey everyone, and welcome back to another video. Today, we are continuing our journey into the world of ethical hacking and reconnaissance. We are going to be diving deep into one of the most comprehensive open source intelligence, or OSINT, tools available in the Kali Linux ecosystem. If you are serious about information gathering, you've probably heard of it, but today we're going to really break it down. We're explaining exactly what the SpiderFoot tool is, how it functions, and how to use it effectively. Before we jump into the terminal in the browser, I need to give the mandatory disclaimer. Everything we are discussing and demonstrating today is strictly for educational purposes and for ethical security testing. We're going to be using high-profile public examples, specifically Google.com and HackerOne.com, to demonstrate the capabilities of this tool. However, you must remember that you should never, ever run active scans or deep reconnaissance on a target or infrastructure that you do not have explicit written permission to test. Unauthorized scanning can trigger alarms, it can be illegal, and it violates the core tenets of ethical hacking. So please, keep it legal, keep it ethical, and let's get started. Let's establish what SpiderFoot actually is. At its core, SpiderFoot is an automated OSINT reconnaissance tool. Its primary goal is to automate the very tedious process of gathering intelligence about a target. That target could be a domain name, an IP address, a specific host name, an ASN, or even a user's email address. In the old days, or if you were doing this manually, you would have to visit dozens of websites one by one. You'd go to a Whois lookup site, then you'd go to a DNS checker. Then you'd search Google for subdomains, then you'd check GitHub for leaked code. It is slow and it is easy to miss connections. SpiderFoot solves this by automating queries to over 100 different public data sources simultaneously. It pulls all that fragmented data back into a single repository, and most importantly, it tries to correlate that data. It looks for relationships between your target and other entities on the internet. Now, regarding the versions, you are absolutely right. There are essentially two distinct ways to run SpiderFoot. First, you have the command line interface, or CLI. This version is built for automation. If you are building a pipeline or a script that needs to run a quick scan and pipe the results into a text file, the CLI is perfect. It is lightweight and headless. However, the second version, and the one we're focusing on today, is the embedded web server mode, which provides a rich graphical user interface, or GUI. The GUI is superior for analysis because it visualizes the data. It draws graphs, creates charts, and allows you to click through the data nodes, which is essential when you're dealing with the thousands of data points that a scan usually returns. So, how do we get this web server environment up and running? In a standard Kali Linux environment, SpiderFoot is often available in the repositories, but many professionals prefer cloning the latest version directly from GitHub to ensure they have the newest modules. To launch the GUI, you don't just type the tool name. You typically need to invoke the script and tell it to listen on a specific IP and port. The standard command usually looks like python 3 sf.py, followed by the -l flag to specify the listening address, usually 127.0.0.1 for localhost, and the -p flag for the port, which defaults to 5001. Once you hit enter in your terminal, the tool initializes its database and starts the web server. You will see a message saying serving on HTTP 127.0.0.1 port 5001. At this stage, your terminal becomes the server log. You don't close it, you simply minimize it. Open up your Firefox or Chrome browser and navigate to that local URL. When the page loads, you are greeted by the SpiderFoot dashboard. It's a very clean, dark mode-friendly interface. You'll see tabs for new scan, scans, and settings. The Settings tab is actually quite important because this is where you can plug in API keys. Many powerful OSINT sources like Shodan, Census, or VirusTotal require an API key to give you full data. SpiderFoot works fine without them, but it works even better with them. Now, let's move on to the actual operation. We're going to set up two different scans to show you how the tool handles different scopes. We're going to add them one by one. First, click on the New Scan button in the top navigation bar. For this scan name, we'll call this Google Infrastructure. In the Scan Target field, we're typing google.com. Now look at the Scan by Use Case tabs below. You have options like Passive, which makes no direct contact with the target, ensuring you remain stealthy. You have Footprints, which is more comprehensive. For this demo, we're going to select All because we want to see every possible module of fire. We hit Run Scan. While that initializes, let's immediately set up the second one. Click on New Scan again. This time, name it HackerOne Portal. In the target field, we type hackerone.com. This is an interesting comparison because while Google is a massive internet backbone, HackerOne is a specific web platform. The type of data we find might differ. Again, we select All for the use case and hit Run Scan. We now have 2 active tabs in our scans list. You'll see the progress bar start to move and the status will change to running. This brings us to the most critical part of the video, understanding what is actually happening during the scan and analyzing the results. Let's look at the scanning process first. SpiderFoot is currently orchestrating hundreds of threads. It's asking VNS servers for records. It's scraping search engines like Bing and Google for indexed pages. It's querying threat intelligence feeds to see if any IPs associated with these domains are flagged as malicious. If we click into the Google infrastructure scan, even after just a minute, the amount of data is staggering. Because Google is such a massive entity, we're seeing a flood of internet name results. These are subdomains. SpiderFoot is finding things like support.google.com, cloud.google.com, but also more obscure development domains. You'll notice a section called Co-hosted sites. This is fascinating. SpiderFoot looks at the IP addresses that google.com resolves to, and then checks what other domains are hosted on those same IPs. For a giant like Google, this is usually their own properties. But if you were scanning a smaller company, this is often where you find they're hosting their corporate site on the same cheap shared hosting server as a gambling site or a spam domain, which is a major security risk. Now, let's switch tabs and look at the HackerOne scan. The data here tells a different story. You might see more results under software version or web server. SpiderFoot attempts to fingerprint the technologies being used. It might identify that they are using a specific version of Nginx or relying on certain JavaScript frameworks. One specific area to look at in the HackerOne scan is third-party presence. Modern web apps rely heavily on SaaS integrations. SpiderFoot might pick up connections to storage buckets, maybe an Amazon S3 bucket or a reference to a customer support help desk URL. In an ethical engagement, these are your attack surface. A misconfigured S3 bucket found by SpiderFoot could lead to a massive data breach. Let's talk about the specific modules running in the background. You have the Have I Been Pwned module. SpiderFoot checks if any email addresses found on the domain, like contact@hackerone.com, have appeared in past data breaches. If they have, it flags them. This is gold for social engineering tests. Then you have the GeoIP module. If you look at the Physical Location tab in the results, SpiderFoot maps the IP addresses to physical cities and countries. For Google, the map is going to look like a world tour, servers in nearly every country. For HackerOne, it might be more centralized in US-based cloud regions. One feature I really want to highlight is the Visualizations tab. If you click this, SpiderFoot generates a node graph. It looks like a giant spider web. The center node is your target. Branching out are the DNS records. Branching out from those are the IP addresses, and connecting to those IPs might be other domains. This visual graph helps you spot outliers. For instance, if you see a cluster of nodes that is totally disconnected from the main infrastructure, that might be a rogue server or a forgotten marketing site that no one updates anymore. Those are often the most vulnerable entry points. You also need to keep an eye on the Errors tab. It's normal to see some errors. These usually happen because a specific API limit was reached or a module timed out because the target has firewall rules blocking the request. Don't panic if you see red text there. It just means that specific source couldn't contribute data.
One thing you'll notice as the scan progresses is the correlation engine. SpiderFoot doesn't just list facts, it tries to warn you. It might produce a high confidence alert if it finds an open TCP port that shouldn't be open, like an exposed database port, or it might flag human name data if it scrapes an About Us page and finds employee names. It automatically links those names to email addresses it found elsewhere. This automated linking is what saves you hours of manual work. To wrap things up, SpiderFoot is arguably one of the most powerful all-in-one reconnaissance platforms you can run on Kali Linux. It balances depth with ease of use. Whether you're a beginner just learning to map out a network or a seasoned red teamer looking to automate your initial discovery phase, this tool is essential. Remember, the quality of your output depends on the quality of your configuration. Take the time to set up those API keys in the settings menu to get the most out of the tool. And as always, respect the scope of your engagement. Only scan what you are allowed to scan. That's going to be it for this video. I hope this gave you a clear, practical understanding of how to deploy and interpret SpiderFoot. If you found this breakdown helpful, please hit that like button. And don't forget to subscribe for more tutorials on ethical hacking tools and cybersecurity techniques. Thanks for watching, stay safe, and I will see you in the next one.